right, so we're going to start with 13.42. A wave oscillates 5 times a second and has a speed of 7.5 meters per second. What is the frequency of this wave? What is the period of this wave? What is the wavelength of this wave? So, this is number 3 in the assignment. And what I would suggest, what did someone put for a Y? What was something you put in there? Christian, what did you put down for a Y for this? Oh, good. So you defined frequency. That's great. Yeah, I would definitely define frequency. What else did other people define other things? Excellent. So you also defined period. Did anyone define wavelength? That would be that's the other concept that's in here, right? Yeah, just showing that you understood the parts of the wave. So that's what I would do for the Y. For the how, we really only have right now one equation: speed equals wavelength times frequency. And oh, actually, we also do have that period equals 1 over the frequency, or frequency equals 1 over the period, whichever way you want to say it. So looking at this one, part A was the frequency of the wave. Well, it tells me it oscillates 5 times every second. And I know frequency is how often it oscillates every second. Oh, so that's just the 5 seconds, 5 per second. So part A, I'm literally pulling from my answer. It tells me that it's 5 times per second, which equals 5 hertz. Part B, scratch your answer. Okay, what is the period of this wave? Here I'm going to use that period is 1 over the frequency. So 1 over 5 hertz, which equals 0.2 seconds. And they wanted 2 sig figs, so 0.20 seconds. If I'm going too fast, let me know, or if you need explanation. Yes. And then the last thing says, what is the wavelength of the wave? So I'm going to use that V is lambda F. I can also write that as speed equals lambda over period, right? I can bring those two together, but so I have a speed of 7.5 meters per second. It's going to equal my wavelength times my frequency of 5 hertz. And so I'm going to get a lambda of 1.5 meters, because I'd have 7.5 meters per second divided by 5 hertz, which would give me 1.5 meters. Let's see if those all work. Sure. Hi. I have a calculator. What type is yours? I think I did pick it up. All right, so mine worked, so I'm going to pause. All right, let's move on to to problem number 5, which is 1344. And it says a wave moves by you with this speed. The distance from a crest on this wave to the next trough is 2 meters. What's the frequency of the wave? Now, I'm going to use a diagram for my y in this one. I could show that I understand the relationship between frequency and wavelength and speed, but I think drawing a diagram here will help me because it tells me the wave is moving this way at some speed, and that from here to here is 2 meters in my case, right? Well, I know that from crest to crest, or from trough to trough, or equal point to equal point, is the wavelength. So in essence, what they've told me is, hey, half your wavelength is 2 meters. So then I'm just going to do v equals lambda f. They tell me my v, 4.6 meters per second. They tell me my lambda, that's going to be 2 times 2 meters. And they ask me for my frequency. Yeah. What is a lambda? It's the symbol for wavelength. It is a Greek letter. It's defined right in your book in the reading that you guys did, and in the video that you watched. But yeah, it's a Greek letter meaning wavelength. So I just do my math now. 4.6 meters per second over 4 meters is going to leave me with 1.15 hertz, because it's going to be 1 over seconds. And then I'm going to round that to 2 sig figs if they ask me to, and get 1.2 hertz, unless they round down, which I hope they don't. So, yes, what can I answer for you? In my problem, they told me the distance from the crest to the trough was 2 meters. And in my y, I showed that from crest to crest, that would be a wavelength. No, because from crest to trough is half the wavelength. That's why I have 2 of them. And so it's kind of like saying from me to halfway to you is 5 meters. How far apart are we? 5 meters. Let's actually physically do it. Jump up and no, you stay there. Between Michaela and I, all right? Well, from me to halfway between us is 6 meters. How far? So that's that little crack where the purple wine bag is. How far is it between Michaela and I if the wine bag is? Yeah, 12 meters. So if from the crest to the trough is 2 meters, how far is it from the crest to the trough to the crest? So how far is it on yours? So how far, what's your wavelength? Let me switch mine up here. Let's try this again. So let's say instead of 2 meters, they told me that this was 6 meters. So from crest to trough is 6 meters. How far in mine would it be from crest to trough to crest? 12. So what is your crest to trough? That's your wavelength. Yep. You already. Now actually try the math again. Wasn't yours 1.9? Yeah. So what's 1.9 plus 1.9? my number works. All right, so 13.9. A tsunami tidal wave travels across deep water with a speed of 750 kilometers an hour and a wavelength of 260 kilometers. What is the frequency of such a wave? And they want it in hertz. So, hopefully in your Y you show what show understanding of wavelength, speed, and frequency. So you should show that you understand what those concepts are. In your how, we're just using v equals lambda f, our speed equals our wavelength times our frequency. And the only thing we're going to have to be careful of is our units. So my speed is 750 kilometers an hour. My wavelength is 260 kilometers. And they want to know my frequency. So I'm going to end up with 750 kilometers an hour divided by 260 kilometers. Which, let me grab my calculator. Which I get 2.885 1 over hours. Now, unfortunately, that's not the unit they asked me for. So I need to change it to hertz. Remember, the hertz is a 1 over a second, so I need to change hours to seconds. So, kind of as a side note, if I have 1 over an hour, remember to convert anything, you have to multiply by the number 1. I want hours up top so they cancel out seconds on the bottom. And hours is bigger, so I make that the 1. And there's 60 minutes and 60 seconds in an hour, so it's 60 times 60. So I get that I should divide by, I end up with 1 over 3,600 hours over seconds. So I'm going to take back to my problem, 2.885, 1 over hours, multiply it by 1 hour over 3,600 seconds, and that'll give me an answer. And I get 8.01 times 10 to the minus 4th hertz. Let me see if that works. All right, so 1392. Now this is another one where I'm not going to solve for the values again. I know you'd never do it on purpose, but the temptation is there just to write in my values since we all have the same values. But I'll talk about it gladly. And, and if you have questions, more than happy to answer them. So you notice a bunch of waves going by you in a certain amount of time, and the distance from one crest to the next trough is 3.0 meters. Oh, we saw that type measurement in a problem we did a few minutes ago. So what are they telling you when they tell you the distance from a crest to a trough? No, half the wavelength. So you want the wavelength, make it bigger, right? Make it so it covers the whole wavelength. They've just told you half of it. And someone remind me, what's the period of a wave? The time for one cycle away, right? Do they tell you that one wave passes you? 11. And in a certain amount of time. How could you find the time for one of them? But you can figure it out, right? You got 11 of them, you got a certain amount of time. The period would be the time that one of those took. And then, remember, we have our relationship here for frequency and period, right? The period equals 1 over the frequency. And then let's move that in. And then the wavelength, oh, we just talked about that. And then, oh, the speed, remember we have our other equation. V equals lambda, the speed equals the lambda time, the wavelength times the frequency. So part D is going to use the speed is wavelength times frequency. Do you know the wavelength? Yeah, because you did part C. Do you know the frequency? Yeah, because you did part B. So see how it builds on itself? Okay. And if you're unsure of your answers, you can always compare it to a neighbor, since everyone has the same answers on this one.